Okay, we're on composition of function. So given two functions f and g, the composite function this. So whenever you see this simple, is called composition of f and g. Is defined by this. For example, let me use an arrow diagram. Assuming x, okay, assuming we have x, this is g, so this is g of x. Y, this is f, so this is now f of g of x. So we now have this. So if you combine two functions in such a way that you substitute the function, one function on another one, so we need to substitute g of x in f of x. But if it's g composite f, we need to substitute f in g of x. So let's use a equation to see what is happening. If f of x is this and g of x is that, find the functions and its domain. So the first one, I told you that f composite g means f of g of x. So we substitute. So since fx is this, if we substitute, wherever we see x, we'll call it what? G of x. So we have square roots. This for this. And x, instead of x now, we substitute square root of 4 minus x. This is our g of x. So which is, that's the fourth root of 4 minus x. And for this to be defined, that's the function. So therefore the domain, for this to be defined, 4 minus x must be greater than or equal to 0. Yes, nth root must be, whatever that is here must be a positive number. So we have 4 is greater than x, or maybe x is less than or equal to 4. So that's the domain. Or using interval notation, we can write this as, using interval notation, or we can write it as 4 is included, 4 is less than, so negative infinity. Now we use this type of brackets, comma 4 included. So that's our domain. So for the second one, we are asked of g, so this is g of f of x. So which is g is this, g of x is this. So we substitute x as that. So that's the composite function. But the domain, for this to be defined, x must be greater or equal to 0, and this must be positive, and 4 minus root x, 4 minus root x must, because this is the square root function, this is the square root function, it must be greater or equal to 0. So we'll solve that. Here 4, if you multiply by, okay, we move this, we have 4 is greater than square root of x, therefore square root of x is less than or equal to 4. That is, x is less than or equal to 16. That's squaring both sides. So if we now combine everything, the domain must be, this is the domain, and this is this one is this, therefore the actual domain must be x is greater than 0, meaning 0 is less than x. That same x is less than or equal to 16. Yes. Or you leave it in interval notation, which is 0, 16, or in this type of square bracket like this. So that's the domain. So the C part. So we have f composite f, which is f of f. So which is square root of x. Yes. So this is f of x inside f of x. So which is fourth root of x. And for this to be defined, that's the composite function. For the domain is now, this must be greater than or equal to 0. Yes. Or writing in interval notations, 0, using the square brackets, infinity using curve bracket. So the D part, G composite G, which is G of x. So this is square root of 4 minus square root of 4 minus x. Yes. So the domain, so for this to be defined, 4 minus square root of 4 minus x must be greater or equal to 0, and this 4 minus x must be greater than or equal to 0. So we solve. This is 4 is greater than or equal to x, or x is less than or equal to 4. Why this is, we move that, we have 4 is greater or equal to 4 roots, square root of, this square root of 4 minus x. Square root of 4 minus x. So if we square both sides, so squaring both sides, I have 16 is greater or equal to 4 minus x, which is x is greater than or equal to 4 minus 16 is minus 12. So x is greater than minus 12. That x is less than, therefore the domain, you see that the domain is now minus 12 is less than or equal to x, while x is less than or equal to 4. Or you write in interval notation, which is including minus 12 and 4. So that's the domain.